In this video, we'll be discussing RAM or random access memory, circuit illustration from Code by Charles Petzold. Now, a RAM is simply an arrangement of a circuit where one can read and store arbitrarily from a set of latches or memory. Okay, so arbitrarily meaning that we have a single data in, and we can pick and choose which of these set of latches or memory we want to store it in. Also, if we want to read something, we will also be able to specifically say which of these latches we want to read the memory from which we want the stored value to be read. Notice that there are three types of components. First is the decoder, second are the latches, and third is the selector. Also notice that there are three inputs: the address, the write, and the data in. The decoder essentially allows us to store a bit arbitrarily by selecting a certain address in a set of latches, meaning we have a single data in, and we can select where we write that data into. If we select the address 000, then it will store that certain data in signal to the latch of the given address 000. Addresses depends on the arrangement of the latches connected to the output in what we call the decoder. Now, since we have the data in their respective addresses, we can now select the data for input. The selector is simply a circuit that allows selection of only a single specific input from a set of inputs. Okay, this is true for a single RAM. But later we will see that we can output more than a single bit if we connect two RAMs together. Notice that although the address input is connected from the same source, we can still control what the latches takes in, stores, or save in the specific address new input through the decoder write input. All right. Here is what we call the 2-to-1 decoder, selector. So what essentially does it selects between B and A, which to output between B and A, which specific signal between input signals B and input signal A should be outputted. All right. Okay, so if we select 0 in this truth table, we shall see that it essentially selects A, while if we select 1, it essentially selects B. So what happens is whatever we put in A, in this case, will be outputted by the circuit. Okay, so let's just say B is 1, which is any value, either 0 or 1. It doesn't matter for B. What matters is what's in A. Okay, so the select input will have has a value 0, and we have a NOT gate here, so it will have a value of 1. We have a value of A from a value of 0 from input A. So what happens is we have a value of B, 1 in B input. Therefore, the AND gates output 0, 0, and 0, or 0 is still 0. All right, so we have proven this specific truth. Okay, so what if we have a value of let's say 0, B is 0 and A is 1. Okay, so again we'll be selecting A if we have the value of 0 for select input. Okay, so this becomes 0, this becomes 1, this becomes 1, this becomes 0. So 0 and 0 becomes 0, 1 and 1 becomes 1, so 0 or 1 becomes 1. All right. So we have proven that this specific truth is real. Now, since this is this is not a random value or arbitrary value, let's say that we have both 1 and 1 for B and A. So what is going to happen is we're still going to output 1, correct? So this becomes 1, this becomes 0, this becomes 1, this becomes 1. 1 and 1 becomes 1, 1 and 0 becomes 0, 0 or 1 becomes 1. So we notice that A is still being outputted regardless of what we select, what we input in B. B. Now let's see if the circuit outputs the B if we select we input a certain one signal on the select. So this we're gonna prove this one. All right. So let's see that this outputs 1, inputs 1, this inputs 1, this inputs 0, and this inputs 0. 1 and 1 becomes 1, 0 and 0 becomes 0, 0 or 1 becomes 1. All right, so it outputted what was in B. All right. Now let's prove this other truth in the truth table where the select input is 1 and we shall select 0 as the value of B and 1 for the value of A. Okay, so theoretically you will be outputting B, correct? So let's figure it out. Okay, so 0, 1, this becomes 1, this becomes 0. All right, so 0 and 1 becomes 0, 0 and 1, 1 and 0 becomes 0, 0 or 0 becomes 0, right? Okay, much like the 8-bit latch, an arrangement of multiple selectors may be connected. Notice that there are 3 select inputs. This is directly attributed to mean that there are at most 8 inputs to choose from. Since the maximum number of a 3-bit binary 111 number corresponds to 8, right? So there's a relation between the number of addresses and the number of inputs available to be selected from. Now we need to arbitrarily store or write a certain input into a certain address. We essentially need a certain circuit that does the reverse of what the selector does. I will show you the decoder circuit in the next slide, but I will not go into detail in explaining it. This is the 3 to 8 decoder circuit. 3 pertaining to 3 digits of binary address, while 8 pertaining to the specific number of latches to be inputted into, right? Here's the truth table for the decoder circuit. Notice that each specific combination for address pertains only to a single specific latch, right? All right. So firstly, we see that there's a 3 to 8 decoder circuit where 3 pertains to the number of addresses, 3 pertains to the number of binary number of bits digits in the address inputs, while 8 pertains to number of outputs of the decoder. Okay, so an 8 to 1 selector pertains 8 pertains to the number of inputs it can take in, and the number of and the and the single output, that is the data out. Okay, so what happens here is we have a single data in connection for all 8 latches. All right, so essentially we'll be saving from this data in. So let's say we have a data in of 0, and we want to specifically store it on in this specific latch, specific latch. What happens is we need to know the address of this specific latch. Let's say the address of this specific latch is 0, 0, 0. Essentially, we're gonna have to input 0, 0, 0 in the address. So what happens is the decoder selects this selects this specific output to have a value of 1. Since this is a value of 1, the output will will essentially be written into the latch will essentially be written into. Notice that this specific decoder treats all other values as 0, or at least connects only to this specific latch, or to this specific address. Now, what if we want 0, 0, 1, 0, 0, 0, 1, let's say, and we want to store the data in of 1? Essentially, the decoder changes the value of this to 1 and changes this value to 0. So essentially, this 0, 0, 1 is the only one being able to store the single data in, where this is the only latch that receives the data in value, or is able to write in the specific latch that is able to write the data in. Although we can say that each and every one of these latches are receiving the data in, since they are all connected. All right. Now, since we have already established that this takes in 0 and this is 1, let's change the address. Let's change back the address to 0, 0, 0. So what happens is we have to mention that the right input will be set to 0. We can assume that the right input will be set to 0. Therefore, this circuit is immobilized, right? There's nothing happening in this circuit. Therefore, we can trust that this specific selection of the address, either we say that this write is 0, or the data. Okay, let's say that the write is 0. Therefore, this part of the circuit is immobilized. Therefore, we can say that this part of the circuit is only one that is working. Okay, so when we select the address 0, 0, 0, our selector selects this specific address and outputs 0. Now, when we change the address to 0, 0, 1, it specifically selects this specific address, which contains the value of 1. Okay, so that is how the RAM works. Now that we have established an understanding of the circuitry of the RAM, we can further enhance it to be able to have addresses of more than 1 bit of storage. As we saw earlier, we were only able to store a single bit of value, single bit. We can combine the circuit in such a way that it can store 2 specific data and inputs simultaneously, for example. Therefore, when a specific address of 0, 0, is called, it will output 2 different stored values from 2 different latches, from 2 different 8x1 RAM circuits. Let's see the specific circuit. This is the specific arrangement or connection that creates 2 bits of output from a certain address. In essence, this is 8x2 RAM. we see that the address is connected to both 8 by 1 RAM, but each 8 by 1 RAM has a different data input. All right, and also both of these RAM are connected to a single write input, so they are simultaneously being written into. All right. Thank you for listening.